have how the effect of NOS with signal strength is shown. Likewise, the interaction effect, which shows the point of optimality for the design. Likewise, for the NOS with signal strength. Then this is the optimality graph. So also we have for carbon monoxide particulate matter with signal strength. It shows the effect at the point where the signal strength can be optimal at certain condition of this particulate. So with the optimization method being adopted, we are able to obtain the particulate at which the signal strength is based for the work. So with the disability factors of 0.997, it's very close to unity, almost unity, which shows the work the model is very effective for the design, and the particulate at which the signal strength is based. And this is the disability factor 0.99 that shows the work is very efficient. So in conclusion, the fact that R-square is substantially greater than R-square predicted implies that the model is of good fit. And secondly, the research essentially established an optimization approach to determine the best fit for correlation of pollutant with respect to radio signal strength. So, consequence of all this foregoing, it is recommended that in the nearest future, further research can be carried out to investigate the reason why particulates fluctuate in terms of their response to radio signal strength. This is with view to obtaining an optimum point for effective radio signal propagation. This is what I've been able to contribute. It establishes an optimization approach for predicting safe threshold below which pollutant must be maintained to curtail signal attenuation and engender better radio propagation. These are my reference for the work. Thank you for listening.
Yeah, thank you very much, Dr. Jimoh Olugbenga Ahmed. I think you have done well. So you maintain 7 minutes the dot. So maybe you have to, sit down for the questions after others might have presented. So thank you very much for your listening. Once again, can you please give him a round of applause? Now, I think the announcement, the next presenter will have to sit on the chair because we learned that some people are online and they have to be watching. And we don't want to stress you the way we have stressed Dr. Ahmed. So that is just it. So the next presenter is will be presenting on characterizations of radio waves propagation through metallic materials. And the presenter will be Robert O. Abolade et al. So you are welcome on ground. Can you please give him a round of applause? Yeah.
Good afternoon, Mr. Chairman, the rapporteur, ladies and gentlemen. This paper is jointly authored by Dr. Ari Abolade, myself, and Folashade Shemiri. And the title, I'm Odedele Dividolaya, and I'm from University of Lagos. the title, like he said, like Chairman said, is characterization of radio wave propagation through metallic materials. And we know that most times when we make communication through our mobile phones, in areas where there are so many melters, those signals tend to fade. They suffer attenuation because of those materials. So we have carefully looked at it, and we now shows two particular metals, copper and iron, as our materials, to see what happens if we look at if we pick the materials with certain thickness and frequency, with the signal is polarized, either horizontally or vertically. What happens to the signal? So we have been able to look at it, and then we simulate the work, and we are able to come up with, to see at what thickness of the material are we going to have reasonable signal transmission and then reflection. So we determined reflection coefficients and transmission coefficients using some mathematical formulations. We have a lot of work that have been done on this in this radio wave propagation through metals and other composite materials. We have analytical work. We have experimental work. So in this one, we have been able to look at it, and then we now came up, but not many work has been carried out, trying to find out, apart from the conductivity of the material, we know always impede electromagnetic waves, signals. So we now decide to, look at, apart from the conductivity, what about the thickness of the material, and at what thickness are we going to have transmission and reflection coefficients? So we have, normally they are supposed to be a geometry. We have it in the paper. The geometry where we look at the electric field intensity and magnetic field strength. Both of them we look at, when in the geometry there is an incident wave and reflected, when the signal is incident on there are two regions here. The first region is the air, the second region is the metal. So when the signal is incident on within the interface of the metal, air and the metal, the signal is reflected, but a measure is also transmitted through the metal. So we have expressions for incident electric field, reflected field, reflected field. We sum up the two waves, and of course in it there must be amplitude. We have amplitude. We also determined incident magnetic field, reflected magnetic field, and again we're able to now also find what is the transmitted field, the signal that's been transmitted. So that one in the transmission region, there will not be reflection, because the signal is not in the region one we have incident and reflection. Then at the second region there's no reflection at all. So we have that, and we were able to come up. Well, the method used, is a method of general solution of wave equations using boundary conditions. So we also impose boundary because there are two regions here. So there will be boundary conditions between the air and the metal. So we were able to do that, and this result is presented in graphical forms showing separate contributions of each of those metals on radio wave signal propagation. And there are several different types of, we generated different plots, and we have the patterns. When the thickness of the metal is up to 10 mm with a certain frequency, because our frequency ranges from 1 gigahertz to 5 gigahertz. Like I said, the thickness of the material chosen between 1 mm and 10 mm. So these simulation results show that when the thickness of the material is so much that we have up to 10 mm with the frequency, both we have vertical polarization, like I said, and horizontal polarization, the signal will the transmitted signal will be at 0, while you have some reflection signals or reflected signals, while the transmission is not having anything. But at a point, if the thickness is not up to 10 mm, perhaps 1 mm, 2 mm, as the case may be, we have some measure of transmission. And so we have been able to find out that because we chose those 2 metals because of their relative availability and the rate at which they are deployed in almost every construction in our environment. Copper is common, iron is common, as well. So each of these materials have their conductivities as we have in the electromagnetic textbooks. So we just pick the relevant conductivity. We now have to impose our own thickness and then shows relevant frequency. And then we're able to come up. And then we can now see. In the plot, we are going to see different types of waves. Patterns of are generated to see that at this frequency and at this thickness, this is what we have. And also for the, and then we also do a call for both vertical polarization, and that is orientation of the wave now, and then the horizontal polarization. And at the end of it all, we have been able to conclude that when we have such thickness, we can have some measure of signal transmission, and the other way around, if the thickness is more than the work we have recommended, there may not be transmission. And of course, the work has not addressed some other areas of it. We have only looked at reflection coefficient and transmission coefficient. We can also determine intrinsic impedance and the power transfer through electromagnetic power transfer in radio wave propagation. And we have some references at the end of it. Thank you. God bless
you. I think we have to, can you please give him a round of applause again? You have actually shown us that you know what you did. That is your work. That it's not anybody that actually did something for you. We are sorry for stressing you. So because it's a stress, but it also shows that you know what you are doing. So on that basis, I give it to you. And you deserve my own applause too. So I think you have to take it. So thank you for the presentation. So maybe we allow the connection to go on before we call the next. Yeah. multiple input orthogonal frequency division, multiplexing system with different modulation schemes over relay fading distribution. And it's to be presented by Ogbomoso the BA et al. Please, can you give him a round of applause, please?
Good afternoon, Mr. Chairman. Standing on the system protocol, my name is Ogbomoso Akinremi, and my co-authors are Professor Zeki Adeyema and Dr. Dio Akande. I'm here to present performance analysis of a beamforming-based multiple input, multiple output orthogonal frequency division multiplexing over a feeding channel. These are my presentation outline. Wireless communication is the process of conveying information from a transmitter to receiver through a wireless channel. Sending a signal from the transmitter to the receiver suffers or encounter so much obstacles like tall trees, tall buildings, moving cars, etc. This results in receiving a copy of a transmitted signal in multiple at the receivers. So in order to mitigate this, the performance of wireless communication system suffers from multiple propagation, such as reflection, refraction, shadowing, and diffraction as explained, which result in intersymbol interference. Intersymbol interference means when the symbol interferes with subsequent symbols, which it happens when signals are received at different time. So, to mitigate this problem, there are a lot of mitigating techniques, which are 1, OFDM, 2, MIMO FDM, and beamforming. So, OFDM means orthogonal frequency division multiplex, when a single subscriber is divided into multiple subscribers. So MIMO FDM is adding multiple antenna at both the transmitter and the receiver of the system. So in so beamforming is when a beam is directed at a particular point or particular angle or direction. So before going to literature review, let me state the statement problem, which I've said some earlier. So in this research, the issue of beamforming came in when ISI suffers from when signals suffer from ISI. So this, when it suffers from ISI, then to cater for the problem of ISI, which is intersymbol interference, but also results in intercarrier interference. That means a carrier frequency offsets. So in order to mitigate the problem of IC high intercarrier interference, then beamforming was introduced into the system. So the objective of this work is to develop a MIMO OFDM based. Is to develop a MIMO OFDM based to solve the problem of ICR. And my aims are: one, to develop a model for LTE network. To develop a model for LTE, long-term evolution network, over a distribution channel. Then secondly, to simulate the developed model in one with MATLAB 2018A, and lastly, to compare the developed model with other existing model like MIMO, conventional MIMO OFDM. So these are my list of my literature review, which I've explained. The problem of the importance of OFDM is to increase data rate and throughput, peak average power ratio. Those are the importance. But the limitations of OFDM is intersymbol interference. Then in the introduction of MIMO into OFDM, that is when multiple antennas are added at both the transmitter and the receiver of the transmitter of the. So the advantage of MIMO OFDM is spatial multiplexing and diversity gain, but it has limitations too, which are complexity. Complexities arises from deploying multiple antennas at both the transmitter and the receiver, and it also suffers from ICI, that is character frequency offset. Beamforming, as explained, beamforming is the formation of beam at both transmitter of beam at a particular angle. We have two types of beamforming. We have blind and non-blind beamforming. Blind beamforming is when channel information is not required, but non-blind is when channel information is not required. We have different types, different forms of beamforming. I've explained the types. We have angular beamforming, Aegean beamforming, and quantized beamforming. But under this, angular beamforming is being categorized under blind beamforming. So therefore, this work addressed the problem of ICI, in which it persists in MIMO OFDM techniques by peripheral researchers, such as insufficient data rates and overlapping of signals, which eventually result in really fading channels. Some of these challenges have not been addressed by existing methods. Methodology. The methodology is based on the objective stated earlier. The development of MIMO OFDM system with beamforming over relay fading channel in LTE network. The developed MIMO OFDM system is a modification of conventional MIMO OFDM. The conventional means there is incorporation of beamforming, particularly angular beamforming, at both the transmitter and the receiver of the MIMO OFDM. So this is the block diagram of conventional and developed beamforming. We have a input signal. That's input signal. We have mapping. When the signals are mapped together, it's then converted from serial to parallel. IFFT, that is inverse Fourier transform. Pilot symbol. Then the signal is converted back to parallel. That parallel to serial converter will work. This work is based majorly on weighted beamforming. That is the incorporation of beamforming at both the transmitter and the receiver. The process of transmitter it will also is the same process of the receiver, only that the signal will be converted back to the parallel. Then the Fourier FFT, fast Fourier transform, is to convert from the time domain to frequency domain, where the IFFT converted from frequency domain to time domain. Then the conventional is below the developed. So mathematical model. The mathematical model is based on the Appian et al. That is the incorporation of the two equations, which are shown in figure 1, where the UR of asterisk is our weighted beam forming. The HS plus N is the MIMO equation, while the summation is the OFGM. Then equation 2 is the summary of I of JL. That we are then the probability density function of the signal for the developed model is given by Ima and Shima 2 and 16, as shown in equation 3, and the modified received signal instantaneous SNR with MRC combiner is shown in equation 4. The modulation scheme used is the spatial efficiency. Spatial efficiency is the same as spectrum efficiency or spatial efficiency, spectrum efficiency or bandwidth. The spatial efficiency or spectrum or bandwidth is given in the question 5. Result and discussion. The results shows the graph for spatial efficiency at different antenna configuration and beamforming angle 30 using MPSK and MQM. The meaning of M is vary. M is when we vary at 16 816 above. So this is the graph. The graph shows the green legend shows that at 16 QAM we have a better performance compared to the 16 PSK at angle 30. The choice of angle 30 is based on the review on the literatures read. So the work can be done at different angles to compare. So the first graph is the first graph shows at different modulation scheme of 16 PSK, 16 QAM, 16 PSK, and 64 QAM. So as we have the higher modulation scheme, we have the better performance in spatial efficiency. So the graph is shown in the graph is plotted from spatial efficiency by SNR. So conclusion and recommendation. The results obtained shows that developed MIMO FDM has helped to increase spatial efficiency over conventional MIMO FDM. This research work is recommended to improve the performance of wireless communication and to mitigate the effect of interference in LT networks. These are my references. Thanks and God bless.
Thank you very much, the presenter. The last person that for this session will be page 11. That person will be presenting on achieving the SDG goal 4 in Oyo State. The need for adequate provision of teachers in primary schools. And it's to be presented by Akambi, G.O. Eh? Yeah. Okay, so let's so can you please give her a round of applause, please?
The chairman, everyone, the title of our presentation is Achieving the Sustainable Development Goals 4 in Oyo State, the need for adequate provision of teachers in public primary schools. We all know that education is very important for meaningful development. In fact, is a vital tool. And that is why the 17 SDG, they are all rooted in quality education. And SDG 4 is aimed at ensuring inclusive and equitable quality education and promote lifelong learning opportunities. But to achieve the SDG 4, teachers must be available. Otherwise, if we don't teach, what knowledge are we going to acquire? And that is why we have come up with this. In the course of our supervising teachers in training, we will discover that most primary schools, they don't have enough teachers. And you know, a good primary school education underpins all the vocational and technical skills acquired anywhere, maybe technical college, polytechnic, or university. And that is why it is critical for the schools to have teachers on ground. How do we achieve educational objectives without adequate number of teachers? And if government continues to invest in buildings, providing infrastructures, what are they going to use it for? It means they are just wasting money if there are no teachers to pass the information across. According to the National Policy on Education, the minimum number of teachers that should be available in a primary school is 15. But the researchers' observation have shown lack of teachers. And many pupils having good furniture, sitting with daily attendance, but no teacher to teach them. So there is a wide gap between the minimum requirements and the number of teachers available in most of the schools visited. The purpose of this research, one, is to survey the extent to which the government has lived up to the expectation of the minimum number of teachers, and to lay bare the situation of things, because sometimes the report that the feedback that the government gets is not the true situation on ground. Then to find out the disparity in the availability of teachers in public primary schools in urban and rural areas in Oyo State, and to call the attention of the stakeholders to the urgency of the need to recruit more teachers into the public primary schools, and to examine the implication of not having enough teachers in primary schools. I've said the minimum number of teachers is supposed to be 50. So our research questions ask, what is the minimum number? Is there a gap between the required number and what is on ground? Are there discrepancies in the availability of teachers in the urban and rural primary schools in Oyo State? And what are the implications of not having enough teachers? The sustainable development goals adopted, we don't need to repeat that. You know, presenters have talked about it. We all know the 17 goals. But what is important is that the goals, once one is achieved, it helps the other. So if we achieve sustainable development goal number 4, it will help in the achievement of others, especially when it comes to education. And this SDG 4 has 10 targets. And when you look at targets 1, 2, and 7, they are all talking of quality education, which may not be possible without availability of teachers. Teachers help students to acquire knowledge, competence, and or virtue. It's a facilitator of knowledge. And in achieving SDG 4, availability of teachers is a major factor. SDG 4 is also crucial in many ways because it's a strong foundation for all other SDGs. And achieving it is hinged on recognizing teachers as primary contributor. So to make SDG 4 achievable, there is a need for massive investment in recruiting, supporting, and encouraging and empowering teachers. This research is a descriptive survey research. It's focused on the description of observed situation. We observed that we don't have enough teachers in the schools. And this research design is supported by Juventus 2020. The descriptive survey research is just a theory-based design where the researcher is primarily interested in describing the topic that is the subject of the research. Our population is all primary schools in all local government, 33 local government areas in Oyo State. And out of the 33, we sampled just with simple random sampling, we selected 21 out of the 33 local government. And the questionnaire used just a simple item containing the local name of the local government, number of available teachers, location, whether rural or urban, the gender of the teachers. The questionnaire distributed was 1,181, and only 600 responded, representing 50.80, which we believe is good enough. Our result and discussion. The research question number 1 says, what is the minimum number of teachers that are supposed to be in a primary school? I've said that, 15, but results show that only few of them met this, and they even exceeded it. We are going to talk about that later, because majority of these local government that exceeded the number, they are in urban centers, and they are Lagelu, Ibadan South East, Northwest, Ogbomoso North, and Oyo East. Research question 2, requiring the gap between the number of teachers and teachers that are available. There is a wide gap between the required number of teachers and the teachers that are available in 16 of the 21 local government areas. Ibarakpa North, Olorun-Sogo, Itesiwaju, Orire, Atiba. They don't have teachers up to 50%. And worst of all is Orire local government. Only 189 teachers for the 44 public primary schools sampled. A shortfall of 471. And in the face of this acute shortage of teachers in the primary school, almost 2,000 teachers from primary school again, they were withdrawn to the secondary school to go and teach, when the secondary schools were also lacking teachers. And yet, Oyo State government has not recruited teachers into the primary school since 2014. And teachers are retiring every year. So we can begin to imagine how many teachers will be on ground. Then, question 3, are there discrepancies in the availability of teachers in the urban and rural public primary schools in Oyo State? There are discrepancies in the availability of teachers between urban and rural public primary schools. The 5 overstaffed local government areas, Lagelu, Ibadan Southeast, Ibadan Northwest, Ogbomoso, Oyo East, majority of them, they are urban centers. And the number of teachers, 164, in 8 schools sampled in Ibadan Northwest is more than the teachers in 24 schools in Olorun-Sogo and 22 schools in Surulere, because those 8 schools, 4 of them, they were in the urban center. A pointer to the fact that teachers are not enough, and this definitely will affect the achievement of SDG 4. If we look at this table, we'll see that Ibadan Northwest, Ibadan Northeast, Surulere, and Orire. Look at Orire has 44 schools. Ibadan Northwest has 8 schools. And Ibadan Northwest has 164 teachers. Why Orire with 44 schools has 189 teachers? So the people in rural area, they don't really have, schools in rural area don't really have enough schools. Then what are the implications of this? In the opinion of UNESCO, teachers not only help shape the individual features of millions of children, they also shape a better world. So Oyo State have not employed any new teachers, like I told you, since 2015. And in some schools, like a school in Sokoto, 10 teachers were available for only 1,170 pupils. So we are now recommending that state government should invest in recruiting, training for primary school teachers, and they should reduce spending and increase investment. What I mean here is when there's allocation for education, and immediately you get the money, the first thing you do is to go and buy the car for the provost, car for the dean, not minding what goes on, whether there are teachers. So that we regarded as spending and not investing. And state government must, as a matter of urgency, close the gap between the number of available teachers in all public primary schools across the state. And primary school teachers in rural areas should have special incentives to retain them, as suggested and done in Malawi and Australia. Thank you for listening.
Yeah, thank you, Dr. Akanwi, for your presentation. I think, well, let us ask, before the question, can you please give her a round of applause, please? Thank you for that presentation. Before we go for the question and answering, we want to know whether there are people who want to present online. So maybe the operator, please, if you have, maybe we take those ones before the question and answer, or possibly we, all of us, give these people opportunity to answer one or two questions from audience. Okay. Yeah. Yeah. Let's allow Dr. Shogutayo. Yeah.
Yes, good afternoon, the chairman and all the participants. Protocol duly observed. I'm here to present a paper titled Numerical Analysis of the Impacts of Thermophysical Properties of Copper Water-Based Nanofluid on the Effectiveness.
This meeting is being recorded.
Of the effectiveness of parabolic trough solar concentrator. Background. Parabolic trough solar concentrator is extensively employed for technological advanced processes, heats, and plant applications such as using daytime sun with virtually no cost. Nanofluids are suspensions of nanoparticle in fluids, which show a significant enhancement in their properties. Nanofood are important for heat transfer in many industrial applications, such as nuclear reactor, heat exchanger, electronics, biomedicine, and food processing. Many parameters, inputs, affect the effectiveness of the concentrator. One of the essential parameters is the type of the fluid, the type of heat transfer fluid, and the mass flow rate. There is need for experts in the field of thermofluid to study the effect of thermophysical properties and mass flow rates on the heat distribution and the effectiveness of parabolic trough. This work presents numerical examination of the influence of thermophysical properties of copper water-based nanofluid on the effectiveness of parabolic trough. So we investigate the effects of mass flow rates, thermophysical property on heat distribution, and effectiveness on parabolic trough. The scope of this work covers mathematical formulation for the description of thermophysical properties and heat distribution in the trough. These are the some of the references which state that the nanofluid exhibited higher thermal conductivity. And the effective thermal conductivity of many nanofluid depends on the nanoparticle size. Metal oxides such as aluminum, copper oxide, titanium oxide were used as the first static nanofluid study. Also, Sogotayo in 2018 presented that the effect of nanofactor has significant influence on the thermophysical property. Also, that the copper has the highest heat transfer characteristics, which is the choice for the nanofluid that will be used for material and method. Description of the physical model as presented by Sakota 2019, which is shown in the figure 1.0. It has a focal length of 0.3, focal aperture width of 1.2 meter, as displayed. The operation of the parabolic trough concentrator. The parabolic trough concentrator uses segmented mirror, as displayed in figure 1, which form the parabolic cylinder to reflect and concentrate the sound radiation towards the absorber, which is made up of copper, and it was placed at the focal length. The setup was shown in the figure 1. Receiver absorbed the incoming radiation and transformed into a thermal energy, which later transported and collected by the fluid medium circulating within the pipe. The fluid medium for this type is copper oxide. Nanofluid. A nanofluid is a fluid containing a nanometer particle size, named a nanoparticle. And the nanoparticle has higher thermal conductivity with high coefficients of heat transfer. So the knowledge of the behavior of the nanofluids are very crucial and important in deciding the suitability for convective heat transfer application. In order to measure the characteristic or to determine the heat characteristics of nanofluid, the following equations were used, equation 1 to 5. Equation 1 describes the effective viscosity of the nanofluid. Equation 2 explain the effective density. Equation 3, effective heat capacity. Equation 4, thermal divestivity. Equation 5 is the thermal conductivity of the nanofluid. And then the heat characteristics are measured using the heat transfer coefficient of the nanofluid as stated in equation 6. The performance of the parabolic trough is measured in terms of the thermal efficiency. Equation 7 explains the actual heat energy obtained or gained by the parabolic trough. And the equation 8 is the thermal efficiency measured for the parabolic trough. Equation 1 to 7, 1 to 8, 1 to 6 are the governing equation for the nanofluid, and the equation 6 to 7 are the concentration efficiency equation. All these 7 equations were solved using iterative techniques, where C+ program was developed to examine the impact of the thermophysical properties on the performance. Simulation procedure. Series of computations were run to carry out the parametric investigation of the effects of the effects of the nanoparticle mass flow rates on the effectiveness of the receiver. The selected fluid, heat transfer fluid, is liquid metal known as copper oxide, and they will vary the nanoparticle from 0.1 to 0.9. Different flow rates were chosen: 0.1, 0.15, and 0.2. The thermal characteristics of nanofluid and effectiveness were determined. The data generated by numerical computation in the field of the fluid mechanics, heat and mass transfer are normally presented in terms of constant line properties, which is called streamline and isoterms. The findings from the simulation. It shows that the increase in mass flow rates increases the Nusselt number. Nusselt number is the ratio of the convective heat transfer to the conductive heat transfer. As the flow rates increase, the Nusselt number increases, which shows that the convective transfer is enhanced, which enhances the thermal efficiency. The density of the fluid was increased, and it showed that as density increases, there's a slight reduction in the Nusselt number, which shows there is more conduction than convection, which reduces the efficiency of the convective transfer of the parabolic trough. Likewise, the specific capacity of the fluid were increased, which shows there is a great increase in the Nusselt number, showing that there's an increase in convective heat transfer, and which leads to high increase also in thermal efficiency. Thermal conductivity of the nanofluid was also increased, and they show a slight decrease in the Nusselt number, which shows that there is conduction more than the convention in the Nusselt number, which reduces the thermal efficiency. And finally, the nano factor was also changed from 0.9 to 0.1 to 0.9, which shows there is a reduction, a decrease in Nusselt number, meaning that as the nanoparticle size increases, there is more conduction factor than the convection factor, which reduces the thermal efficiency. These are the profile generated from the simulation as discussed above. Efficiency for nanoparticle. As the nanoparticle increases, the efficiency reduces, so there is more conduction than convection in the system. The specific capacity is the figure 3, which as specific capacity is increasing, the thermal efficiency also increases, which enhances heat transfer. Figure 4, efficiency versus density. The density increases as the thermal efficiency reduces, which shows there is less conduction, less convection in the system. Likewise, equation figure 5, efficiency versus thermal conductivity. As thermal conductivity increases, there is thermal conduction, which is high in the system, and then it reduces the thermal efficiency, which is based on the convection heat transfer. Equation figure 6, Nusselt number versus heat capacity. As heat capacity increases, the Nusselt number is increasing, which shows that heat capacity is an enhancer for the convective heat transfer, which is the main factor that affects the Nusselt number. Also, figure 7, Nusselt number and density, as density reduces, the Nusselt number reduces. Figure 8, which shows the Nusselt number versus the thermal conductivity. Figure 9, Nusselt number versus thermal nanoparticle size. In conclusion, the research shows that nanoparticle size has significant impact on its distribution, and the nano density thermal conductivity increase with decrease in thermal efficiency of the parabolic trough. It also shows that the specific capacity of the nanofluid as the main enhancer for the heat transfer rates. Increase in specific capacity of the nanofluid increases its heat transfer coefficient and enhances the effectiveness of the parabolic trough. The outcome of this present research are crucial for the industrial applications such as space heating. These are some of the references. Thanks for listening.
Yeah, I think you can hear us here. Thank you for your presentation. I think you took to the time, and that's very fantastic. Yep. Any other online presenter? has two papers. India. Okay, what's the name of that person? Name, so that you can. I don't. Second presentation, Agbolade. Okay, okay. That's applications of lab-based transforms to cryptography using the linear combinations of functions. No. Check. I think maybe change his topic, because the topic there is quite different from what we have here, although there is semblance of. Are you sure this is what is here? Okay, it changed the topic. Oh, okay, okay. So what we have here, maybe you have to change it here.
Sorry, let me share the document. Okay, this is it. Yeah. Okay, sir. Can I come in, sir? Okay, good afternoon.
Go ahead, please. Hello, Doctor.
So I will be presenting this work. So this is the table of contents. So I'll go to my abstract. Now, information security is an integral part of the rapidly developing world of technology. A lot of data being used by devices and for the formulation of algorithms has to be properly secured to avoid it getting into the hands of fraudsters or hackers. If you will notice some years back, the WhatsApp, when you open WhatsApp, you have this message that comes in that the message between two individuals is end-to-end encrypted. That is, for every chat that you have with any individual, there is encryption for that chat, that it is secured, not just holistically, but for that particular chat, it is secured. So we see that cryptography is actually very important in the rapidly developing world of technology. Now, in this work, we propose a symmetric scheme that uses the linear combination of the series expansion of exponential function and hyperbolic cosine function, which is the cosh function. Now, the encryption and decryption process follows a series of processes, and both processes of encryption and decryption process are both compressed into a single function to aid the stress of programming and future implementation. Now, as I proceed in the presentation, we'll see the function. The introduction. Cryptography, so many of us actually use this area of science, but we might not be familiar with it, probably because it's not our field, but it's something that is very important. From our text message, simple text messages that we send, from images that we send, from audio files that we send, cryptography is in place, is being used. Messages are being encrypted for security purpose. Now, there have been several existing cryptographic schemes. We have the RSA cryptography, we have the AES, we have DES, and several others. And also, cryptography is categorically divided into two. We have the symmetric cryptography and the asymmetric cryptography. The symmetric cryptography is when you have a sender, a receiver, and then you have a key. That is, there's an algorithm, and then there's a key that encrypts the information, is used for encryption of the information, and then the decryption of the information. Now, in the asymmetric cryptography, we have the sender, receiver, we have the system, the cipher, then we have the public and the private key. The public key is used to, is sent publicly, while the private key is at both ends. That is, the receiver has a private key, the sender has a private key. So, but for these, we'll be discussing about the symmetric cryptography. And one thing we might ask is that, okay, what's the essence of this new cryptographic scheme? The truth is that from time to time, new cryptographic scheme has to be developed. Before, elliptic curve cryptography was considered one of the most important, one of the most secure cryptographic keys. Before that was RSA. But over time, these cryptographic schemes show the weakness is discovered, and then there's a need to develop more, to develop better ones. Like in 2015, NASA announced that it plans to transition to quantum resistant algorithm from the elliptic curve. Now, these are just some definitions, but because of our time, I'll just skim through it. We have cryptography there, the cipher, that's a system that converts either from the plain text to the cipher text or cipher text to the plain text. Now, this is a review of previous work. This work actually is an extension or a review, or let me say, an extension of ADFI et al. Work, that's 2021, where the linear combination of exponential and the hyperbolic sine function was used as the integral function of the symmetric scheme. Now, this is a Laplace transform. We have Laplace of f of t here, the definition of a Laplace transform, and then we have the definition for the inverse Laplace transform. Now, to encrypt a given information, now let's select a message Q to be sent and convert each letter to a number so that we have the following. We have space to be 52, Z to be 51, and like that. We can use some other form of denotation of conversion system, but for this, for illustration, we'll be using these. Now, this step 2 is to convert the text you want to send. Let's say we want to send welcome, the word welcome. Now, welcome, W will mean 22, E will mean 4, L will mean 11, and like that, E will mean 4. Then we convert this to a sequence of number such that the first letter becomes Q0, the second one becomes Q1, the third one becomes Q2, in that order. Now, we consider the series expansion of exponentiality and causality. So we have it here, the series expansion of exponentiality and causality. Now, adding this together and then multiplying by t, we have this series. We have this here, this result here, that's given by equation 6, where NPR is actually n permutation R, which is defined as n factorial over n minus R factorial. So let's consider this function, f of t equals to qt e exponential 2t plus cos 3t. Now, in this case, we have we're just trying to see when we have R to have a specific number, what will be our result. So here we have f of t is given as this. Then when we expand it, now we are going to expand up to n equals 7 because of the length of our information, which is welcome. So we have it here, this expansion here. Now moving on, we substitute, that is the Q0, the Q1, the Q2 that we have, we substitute into this function, and then after that we simplify and take the Laplace transform of that function, then we have it to be this. So after taking the Laplace transform, we have the equation 12. That is Laplace transform of f of t equals to 44s raised to power minus 2 plus 24s raised to power minus 3 plus 45s raised to power minus 4, and on like that. Then to step 5, we find EI such that delta I plus rho I mod 53, where PIs are the corresponding power of the variable S. That is, for that equation 12, we have 44 s raised to power minus 2. Now, each power of that expression, of each expression there, that's 44 s raised to power minus 2, 24 s raised to power minus 3. Each power there, the value of each power there is what we have as our PI. And then the DIs are the coefficients of the firm in equation 12. So this table presents the computation. We have 42 plus minus 2, 44 plus minus 2, we have that, 24 plus minus 3, and on like that. Now we have some series of values. Then this value EI above will be the encrypted message. We use our conversion system in step 1 to convert these numbers back to letters. And then after that, we need to obtain the key, because encrypting an information without the key, even the sender, if he doesn't have a key or a way to generate the key to the message as encrypted, he has actually not done any work, because there's no benefit encrypting a message that you yourself cannot understand, you cannot decipher it. So we use this formula to generate the key. This is based on the modulo operation. Thus, the key obtained is given as this. Therefore, the message to be sent to the receiver will be the ciphertext given as that Q, V, E, Z, W, Z, L, J, P, D, and the key 1034147, like that. So, now to the decryption process. The decryption process is more or less like the reverse process. To decrypt the message that we have received, we use the following, we apply the following process using the same conversion that we used to encrypt. That's the same conversion we used to decrypt. So we convert those numbers to letters, and then we expand f of t up to 3n minus 1 to 10 if the length of the ciphertext received is odd, and 3n over 2, 10 if n is even. Now, we obtain the f of s by taking the Laplace transform. Then, from there, we obtain I from the power of s in f of s. We obtain I, so we compute the delta I by using this. Now, if you observe this closely, this is just like making subject of the formula the key formula that was presented in the encryption algorithm. Now, we substitute the chosen values of R, sent, and then we compare the resulting f of s term to obtain the plain text. Symmetric key cryptography is still in use today because though asymmetric is in a way considered stronger than symmetric key, but symmetric key, because of the simplicity, or not so simple, not simplicity in that sense, but in comparison with the asymmetric key, it's quite simpler. So symmetric key is used to encrypt, and then the key of the symmetric algorithm now is now encrypted using the asymmetric cryptography. So it is still useful. So in conclusion, the increase in the length of the input plane is good, as it helps reduce the probability of getting the answer. That is, by brute force attack, the length of the message, original message, and the length of the output message sent varies. So by brute force attack, just using the number of possible combinations of words. Let's say if originally the 5-letter words were to be sent, and then when you encrypt, you also get the 5-letter words, someone can actually perform the number. But okay, what is the total number of words that 5-letter words I can have in the English language, and the results can be gotten. So, but by the time the length of the output text and the input text is not the same, the probability of getting the original text reduces greatly. Now, in this proposed work, we improve an innovative cryptographic scheme using the process of linear combination of functions. And the key is the number of multiples of mode 53. That's an error, sorry. Now, the function provides numerous transformation as per the requirement, which are the most functional factor for changing key. When we change our value of R, the key will get to be different. The ciphertext will definitely be different. So, and that's so. Here are some of the materials used. Thank you for listening.
Thank you for your presentation. I think although you have taken more than the required time, so we employ you that when you are presenting an international paper, you just have to take to the time, no matter maybe patient. And at the same time too, I want to quickly correct your this thing that abstract is presented. You don't have to waste your time in presenting the abstract. Just go to the title, the introduction, or the literature review, and your methodology and the rest of them. Although your presentation, you have done a very good work in terms of the methodology you have, but I just want to that such attitude of abstract should be in future presentation. Thank you.
All right, thank you.
Any other?
Do we still have anyone wants to make presentation? Do you have anybody?
Yes, sir. I want to put on my laptop. Can you just give me like 5 minutes to set up, sir? Or else I have to use my phone.
Okay, just try to use any of them. If you use your phone, you can change the orientation. And then because we are projecting.
Okay, just give me 2 minutes. Okay, sir. Just give me 5 minutes, sir. Let me get myself ready.
Do we have any other person who wants to make presentation, please?
Hello, can you hear me? Good afternoon. Sorry, my presentation is scheduled for tomorrow, so around 11. I don't know whether this breakout room is where I'm going to be presenting it. That's session C1.
Okay, tomorrow, no problem. We'll take it tomorrow.
Okay, is it on this breakout session, this group?
Oh, yes,
room 1?
Yes, tomorrow.
Okay, all right, thank you very much. All right. Thank you very much.
Who is supposed to make presentation today and who has not been able to make his
Yeah.
Any other? What? Who? The presenter. Maybe while he's doing this thing, then we have to attend to those people who are presented. And
Can you see my screen? Oh.
Now, because we cannot waste 5 minutes waiting for somebody now, because we have question and answer. So maybe we give him in the next 10 minutes. If he's ready, we'll present, so that all of us attend to those people who are presented before. Okay. Or what's your own take? Or we should accommodate him. We should wait for 5 minutes for him to get himself ready. I don't think that is. Okay, let's go for the. Yeah. I have to, thank every presenter for this, for a good job done so far. The floor is now open for question and answer. Yeah.
My question is directed to. My name is Ajayi Julius, Department of Transport Management, Lautech. Department of Transport Management, Lautech, Ajayi Julius. My question is directed to the last speaker that presented physically, Dr. Grace from Emmanuel Alayode. The topic about the SDGs 4, about quality education, where she dwelt on quantity of teachers. I want to ask first that, is there a scientific basis for allocation of teachers to schools? What I mean by that is, I think you mentioned in your statement of problem that the number of teachers that are expected to be in a particular school is 15. Now, is there a provision for teacher to student ratio so that we would know if that number might be okay for some schools and it might not be okay for some other schools where they are overstaffed or short-staffed? And secondly, the focus is quality education. Does this quantity you have dwelt so much on guarantee quality delivery of education? You would agree with me that there are times that some teachers are well competent, that they would be able to do, sometimes, be able to justify the work of more than one teacher. Whereas, there are some teachers that would not be able to justify, maybe 2 or 3 who might not be able to justify the work of one teacher. So, how do you close the gap between quantity and quality of delivery? Thank you.
Okay.
Very much. We thought we are going to make copies of our paper and give to everyone. But when we go to we discovered that there is nothing like that.
Yes, so
The national policy on education. There is a document. National policy on education by the federal government. In the policy, the minimum, remember I talked about minimum, the minimum number of teachers that should be in a primary school is 15. It's written there clearly in the national, in fact, it's in the full paper. And I said in the body of the paper that we are not looking at quality now. Because you can begin to talk of quality when something is available. We are saying something is not available, then you are talking of quality and effectiveness. Let us make them available first. You are thinking a teacher can take 4 courses together effectively. It is because of the situation we find ourselves in Nigeria. There has to be standard. You cannot be jack of all trade and master of none. You can have your PhD in primary education and you'll be teaching in the primary school in the whereas here in Nigeria, you have people who have not even been to teacher training college at all. They are teaching all over the places. So that is why I want to address the quantity first. Let's make them available. After that, then we start thinking of capacity building and things like that. Thank you.
Any other question? I have this something for you. This is on, SDG, go for, which is very, very germane. Without that, I don't know why they put 17 to be the main. I would have been a common denominator, but they have decided to use 17 as the general for all, while 4 is one of the things that is being assessed or what have you. I would have loved a situation where they put 4 as something that is common denominator for all of them for the assessment, rather than what it is. But whichever way they have done it, our goal 4 remain sacrosanct. And that is why I want to ask some of these clarification and basic questions for you. And all of us, I put something there, I say, what do you think might be responsible for the shortage of teachers? Because that is one, you have to, you have been talking of shortage of teachers here and there. And based on your own assessment here, while you are conducting the research, one would have expected to put certain questions that what the thinking of those people to actually enable you to have some influence in that particular regard. That is one. 2, the second one is, why do you think the presence of teachers are more in urban area than that of rural areas? So some factors might be responsible for that. And those things supposed to have even been incorporated into this thing there. So if you have done it, well, maybe maybe you have to follow up for the educator. And the last one is in tandem with what he has actually said, and I put it there. First, what is the UNICEF recommended staff-student ratio? If you keep on saying teacher-student ratio, if you keep on saying minimum is 15, they're supposed to give us minimum number of students too that have to corroborate. Because I know in developed countries, in Germany, for example, if you have 50 students to a teacher, 15 students to a teacher. Once it succeeds, you have to divide that one. Because some of us who actually have the opportunity to interact with them, even when you go to institute or that issue, and you have similar thing. Rather than primary school that we have, you still need a lot of energy to interact with the children and what you do. So these are some of the things that I want you to actually give us. Thank you.
Yeah. One of the issues. Hello. We were almost tempted to incorporate the reasons why we have, why we are not having enough teachers, especially in the rural areas, and go into details. But we didn't go to details because it's just like it's glaring that teaching in our rural areas is like going to hell. I was allocated a school in Ogunda. That Ogunda is a village after Fashola. We got to the school. I met only one teacher in the old school. We are the others. He told me that they rotate. Somebody will come on Monday, another person on Tuesday for 6 classes. And in the national policy on education, it is stated clearly there. And they suggested a teacher to 36 in the national policy. But though it's higher than what UNICEF is recommending. In fact, in that national policy, they recommended subject teachers. That is what used to be when we were young. A teacher will teach mathematics, primary 3, 4, 5. But now, a teacher, like my brother said, teaches all. And that is not good enough for our education system. It's one of the problems that we are having. And again, we discovered that the feedback that the government is getting is quite different from what is on ground. If you ask them, why are we not having enough teachers in the rural areas? Well, they don't want to go to the village. Are you making the village comfortable for them to wanting to go? And one thing we discovered again is when you go to schools in urban areas, they are filled with wives of commissioner, wives of permanent, especially in Ibadan, wife of this, and you get to a school where teachers are almost more than the pupils. That is one of the table that I showed. They had 136%, you know. So it's I think our government is not really committed to having more teachers in the primary school. They thought, well, teaching in the primary school is something that is anybody can go there and teach. But more importantly, we are having scarcity of teachers in the rural area because the rural areas not conducive. And that is why we are making a suggestion that probably if you have a package, an incentive for teachers, like it was done in Australia and Malawi, and I think Russia does that too. People want to go to the village because they know that at the end of the day, they get extra money. But here, nobody knows whether you are going there or not. Even the inspector will not go to these schools to know whether the teachers are available or not. Yeah.
Thank you very much. Just try to incorporate that into the something there. I understand. That is, you know, in Nigeria, it's always good to make some assumption that way. There must be, there may be a lot of, you know, underlying factors, you know, preventing or precluding people from going to rural areas. And that is why your study the questionnaire must be administered in such a way that those people who are there will be able to tell you their problems and will be able to analyze all the problems and analyze them and present it to government. Because government does not want to be hearing the normal thing that we don't want to go there because of incentives. It may go beyond incentives. Maybe there are certain factors that government needs to know and therefore need to put in place for them to do that. Thank you very much. So, any other question? Question? Yeah. I have for the presenter one. That's Dr. Ahmed. You made mentions of effects of particles on the radio signal strength. And you try to, examine some pollutants, effect of some pollutants, like this thing. My observation there is that although while you are presenting, your presentation is very explicit enough, but I know that the nomenclature of some of the pollutants that you use, we have to go in line with the IOPAC. That is, you made mention of carbon monoxide. It is no longer carbon monoxide. That's the old something. You have to come back to carbon 2 oxide. And carbon dioxide, carbon 4 oxide, and the rest of them. So I have that kind of observation, and you have to, incorporate so that so when you are publishing this thing, it's also in there. Then my question is that, I say, what is the best particles among all those ones that you have, evaluated to favor the radio signaling strength? And why do you think that one that you have mentioned is so? I think you understand my question, sir. Yeah.
Thank you for the observation, Mr. Chairman. Based on the studies, which is actually the effect of those particulates on radio signal strength, mostly the signals usually comes in a form of a continuous form, which is analog in nature. But when it is processed, it will be digitalized, which initially started by sampling, which we actually did in our center at Center for Atmospheric Research. So they were able to sample those particulates. And in all, the way they behave with the signals was actually deposited with some of the findings I made from the work. But out of them all, I actually try to obtain the threshold level at which signal behave very well. So the essence of that optimization is that at times you need to minimize some so as to achieve better signal strength. But when you look at the result of the study, the sulfur oxide actually has a, when you compare with others, the effect of sulfur oxide on signal strength is not as that of other particulates. So that shows that when we want to modify the model, the degree at which sulfur oxide will be reduced, that is delay, which is in signal times, will not be as that of other particulates. That is the essence of it. Thank you.
Thank you very much. Any other question for the presenter? Yes, for Robert Adebo Wale. Is it Robert? Robert Adebo? Yes, you are the presenter too. You are the one that presented on the. Yes, I think we did it with that slide. Yes. I just want to commend you. Unfortunately, we couldn't see the way you have done it, but I just, if you have it there, I told them that they just have to run through. Not necessary that you have to speak to them, but for your slide to, to reflect on our distance there, please, if you, yeah, please, give him 2 minutes to just go to something. Just tell us the objectives. Just use the something to replicate the objectives, and the findings. Yeah. So that people can see.
Yes. Good afternoon once again. The title is actually characterizing on radio wave propagation through metallic materials, and we have found out that when we make communications with our phone, and we have only been having, the subscribers always have challenges, even the network engineers. And of course, we knew, right, as it is recorded in literature, that conductivity of different materials, metallic materials, actually impede electromagnetic transmission. So apart from that, what other things do we think can also impede electromagnetic radiation transmission? Apart from, when we are talking about metals now, we have different type of metals. We have composite materials that they will use epoxy and copper, that they will use for the aircraft and spacecraft because of the lightweight and the thick and the strength. So we went into it, and we have there's a particular geometry. There's a mathematical geometry. So to be able to find out the equations and the expressions, to find out, okay, when there is an incident signal between the interface between the air and, because there are two regions. We have the air and then the material now. Because if I'm making communication now, yes, I'm sending signal now, but it will go through certain channel and all that. So, okay, this is the geometry. So we have the incident signal, we have the reflected. There will also be reflection. Although in some materials, like the one we call perfect conductors, we need total reflection, like the one they use for the dish antenna. Yeah, exactly, sir. So it will go and everything must reflect. But here now, we want some measure of transmission. And that's why we have it going to the region 2. So we found expressions, incident electric field, ice incident, and then of course there must be propagation constant, then that's gamma, and then alpha 1 and beta. The alpha is attenuation constant, and then the phase constant. So we have the reflection expression too. Yes, sir. Yeah, I'll go there. So we compare two material, copper and iron. We can also go pick a steel, but each of them has different conductivity. So we now use the same thickness for the two. With the same different of course they have different conductivity and then the frequency of propagation. So when we do it, there's a response or the pattern. Go down, sir, to the final towards the. So we have that's Fresnel reflection coefficient. Go down, sir. Go down, sir. So we are able to get okay, yeah. So we have this with the transmission coefficient for copper and iron against angle of incidence. So we have this 1 gigahertz with 1 mm vertically polarized. We see that for the blue is copper and the iron is red. So the copper here is giving us zero transmission because of the side. There's no transmission because we call it as higher conductivity than the iron. So the color we know it actually it terminates electromagnetic signal. So the conductivity is now making it difficult for a signal to be transmitted. So because with that frequency and the width, but in some cases when we go down, we also have a situation whereby we have some measure of transmission with okay. Sorry. Okay. Okay. Here we have horizontal polarization. Yes. Here now, because the width is 10 mm for the two. It's too thick. You know, when we add 1 mm, we add reflection coefficient. There was a transmission for iron, but for copper it was 0. But in this case now, the two of them are they overlap, and then there's no transmission for both. So the thickness now is a very paramount. When we are selecting materials for construction, we need to. The thickness of material is very germane. We need to take consideration of the thickness we are going to use so that when the thing is final, when we are under some buildings, we cannot have transmission. When we are under some other buildings, we can also have. Okay, sir. Yes, sir. Okay, sir. Yes, sir. Okay, sir. Yeah, there is reinforcement. There's reinforcement inside, yeah. To make communications, yes, sir. You mean Lagos State University, sir? I've been there. When you're in Faculty of Engineering, it's very difficult. Atekpe is always difficult. I've been there. Yes, sir. So when we are doing so, the important consideration must be given to the thickness of those materials we are using, especially the iron, because there cannot be strong without reinforcement. So that is why we have been able to investigate. Apart from the conductivity, what else can we do? It's not recorded in many literatures. So that's why we were reading, and then we are able to simulate, and then want to even extend it to look at, okay, the screen depth and other parameters that we need to look at. Yes, sir. That's what we have done. You're welcome.
So thank you very much. There is another person, paper 3. Well, that's the local paper. That's Dr. Ojenrinde. Yes, I only have observation. You see, the observation I have, people may have questions, but I have observation. Yes. The observation I have is that whenever you are presenting, you have a clearly defined objective. You see, not that you have to, since you have other things there, people would like to focus on that. They are, irrespective of field of endeavor, standard way of presenting is paramount. And I know in engineering and what have you, their own is actually different from what obtained elsewhere. So that's because all along you didn't show us your objective, the aim of the study, and some other things. Then another thing that I observed in your presentation is that you have some acronyms. You just put some acronyms. Before you put acronyms, you must all of us tell us the minutes, put the acronyms, and subsequently you'll be using them. But you don't expect everybody to just be cracking their brain on the acronyms that you have used, and then later you now show us the acronym, and that is it is not always done that way. So you have to improve on that. And finally, in your conclusion, you are unable to tell us true why you compare two things here. You're conventional. You say something is conventional. We are developed. You see, you did not tell us which one is more distinct. And when you even say something on that too, you did not tell us the reason from your own finding why your result is that, except you want to further, strengthen on that for us.
Thank you, sir. According to the graph presented, sir, I plotted the graph of conventional and developed. Yes, and I explained it that the conventional, the line for conventional and the developed, according to the SC spectral efficiency I used, the developed will be higher than the conventional, according to on the graph which shown. So I compared the modulation scheme and at different antenna configuration too. So, but in my conclusion, it wasn't stated as you said. Thank you, sir. According to my methodology, sir, I'm not yet. According to I explained a little that my received signal incorporated. Yes, sir. This is, sir. And this is the efficiency I'm talking about. To my result and discussion, sir. Yes, sir. So I explained that I said the two modulation schemes used were MPSK and MQAM. PSK phase shift skin and quadrature amplitude modulation, sir. So I said it earlier that M is to vary from 16 to 1632, and I said it when.
You see, you don't cut corner when you are making presentation. Do you know what? The key aspect of something is supposed to be put on the something. You have to do the explanation. But at the end of the day, I was following you. I may not be in your core area, but I was following you something there. Eventually, I just saw 16 AP, 16 QAM, then 64 QAM, and something of that nature. And there was no way in your presentation where you have highlighted that this is, and that is just it. You know, you may have a very fantastic, work, but if the presentation is not there, then what is it? Because we are here to look at it so that if there are some loopholes there, we'll be able to